All right. So in this case, I want us to consider our partial fractions in the integration that we are given. So considering our April 2024 exam, so there we are asked to use the partial fractions to calculate the following integrals. 3.1, you're given this integral. So let us consider how are we supposed to integrate this with respect to x. So this is question 3.1, where we are asked to integrate x to the exponent of 4 minus 3x squared plus 7x plus 3. So this whole part is divided by x to the exponent of 3 minus x squared minus x plus 1 with respect to x. And that is 7 marks for that. So if you're to consider this question that we are given, the first part that we'll see is that the numerator that we are having is having the higher degree compared to the denominator. So if whenever, remember the concept of our integration, the numerator must have it must have a lesser degree. It must have a lesser degree than the what? The denominator. So in whatever concept where you see these being equal or more than, like what we can see, it is more than this, or when it can be equal, whenever that happens, you're supposed to apply the long division first so that you can have a lesser degree on the numerator. So in this case, there was a need for us to apply the long division first. So you must be very, very careful with the condition that you are given. So in this case, applying our long division, that is x cubed minus x squared minus x plus 1 into this whole expression that you're given, which is x to the exponent of 4 minus 3x squared. So as you can see, we do not have the part of x to the exponent of 3. Remember, the order is supposed to be 4, 3, 2, and so on. So the part that you do not have, you can just represent with 0 there. So that's, we've got 0x cubed. Then we can maintain the remaining minus 3x squared and so on. So that is minus 3x squared plus 7x plus 3. So you're going to take this part as it is. All right, so let's divide and see what you're going to have. Remember the division, always the first term to the first term from our N3. So that is going to be x to the exponent of 1. That is, you multiply back to this whole part that you're given. So it's x and x cubed, which is x to the power of 4. With this minus x squared, that is to the exponent of 3. With this minus x, that is minus x squared. And with this one, it is going to be x. You're multiplying everything by what? By this x that you got. Then we can subtract. So remember, there we are going to subtract what we got from the multiplication. So that was going to cancel this part. All right, there we've got a 0 minus minus. So that was going to be a plus. So that's x cubed minus 3x squared minus minus 1. So that's minus 3 minus minus 1, which is simply a plus. So that will be a negative 2 there. So you're going to have negative 2x squared, 7 minus 1, that is a 6. So this is what we are going to obtain from the subtraction. Then we can just drop the remaining term, which is plus 3. So let's divide again. Remember the first term versus the first term. So the x to the exponent of 3 and this one are the same. So that is going to give us a direct 1. So that's plus 1. Then you multiply back everything that you have. So it will be x to the exponent of 3 minus x squared times this x, which is minus x, which is the negative x, then times this one, which is going to be a positive 1. Then you can subtract just like the previous case. All right, so that was going to cancel here. Let's see what are we going to have. Negative 2 minus minus 1. So that's a plus there, which was going to be negative 1. So that's negative x squared. All right, then we also consider the part of x here. That's 6 minus minus. So that will be a plus 6 plus x, which is simply 7x. So that will be 7x, 3 minus 1, that is a positive 2. So in this case, we can notice that we cannot divide this to the first term. It's impossible now because we are going to have a fraction there, minus x squared like this, divided by x cubed. As you can see, these ones will cancel with these ones, then we remain with x, which is a fraction, and you cannot present fractions. It means that is our remainder in this case that we are obtaining here. So there we are obtaining the remainder. So remember the concept of our division. When we divide, you are going to obtain the exact factor, which is the exact term that you are given, which is our expression of x plus 1 from our division that we got. So meaning to say, the whole of this part that we had, guys, the x cubed, whatever that we had, there can be written as, after this long division, let's just try and rewrite what we're supposed to have there. So this is going to be taken as x to the exponent of 4 minus 3x squared plus 7x plus 3. Remember, this was our question, over x cubed minus x squared minus x plus 1. So this was our question, remember? So this is equal to, you divided and you got the exact term, which is x plus 1, plus the remainder, which is this remainder that you got. So you're going to add the remainder. So our remainder is what? Our remainder is minus x squared plus 7x plus 2 over what was dividing. You were dividing by what? X cubed minus x squared minus x plus a 1. So this is what we are going to deal with in our partial fractions now. We divided, so this is the exact part, which is fine. But the remainder part, this one, still has to be expressed into partial fractions. So the question is, looking into this, is it possible now? All right, as you can see, the numerator is having a lesser degree compared to the denominator. So we can think of that expression into partial fractions. But now, if we were to consider this, remember, for us to have this into partial fractions here, from this part that we had, this is supposed to be factorized, which is the same part that we are still having here. All right, so let me just rewrite here aside. So we are going to express minus x squared plus 7x plus 2, the whole of this over x cubed minus x squared minus x plus 1 into partial fractions, which is the remainder now into partial fractions. So if you are to consider this denominator has to be in a factorized manner, we can't work with a single expression like what we have, that it must be brackets, something that we can consider. But this is not exactly what we have. And we are used to a condition where you just have those basic brackets. But in this case, guys, you are the one who is supposed to do that. So in the simplification now, you are going to notice that in the factorization of this, we are now back to, in fact, this is our N1, where we were factorizing these. Remember those long division N1 and also the N3 part. So we are back to that part again, because that's a cubic expression that you're given. Remember how you factorize a cubic expression. We need to factorize this. So to factorize a cubic expression, x cubed minus x squared minus x plus 1, in order for us to factorize this, we have to think of a factor. Remember, guys, our N3, this is the major part of our N3, where you talk of the factor and remain theorem. Just make sure that you go through that part. So we need from the constant, which is 1, factors of 1 plus or minus 1, which one that we can substitute. And if you substitute that, you must obtain a 0 from there. All right, so let's try a 1. We just substitute f of 1 in whatever that you are given here. f of 1, whatever that you have, that will be 1 minus a 1 minus a 1 plus a 1. So this was going to give us a 0. So as we can see, f of 1 is giving us a 0. Remember, guys, from your N3, if you substitute f of a and you obtain a 0, what does it mean? It means, therefore, x minus a is a factor. Okay, the same way, if this was a negative, f of minus a gives you a 0, it means, therefore, x plus a is a factor. So that was from our N3. So this is a plus. So what does it mean? Therefore, x minus, you introduce a negative there, x minus 1 is a factor. So if x minus 1 is a factor, then we can use the long division. We're back to the long division again. Remember, guys, your factor and remember remainder theorem. Having a factor, you have to divide by that, just like what we saw previously. So x minus 1 into our f of x, which is x cubed minus x squared minus x plus 1. So that you obtain another factor by dividing with a factor, you obtain also another factor. So the division does not change first term to the first term. X cubed divided by x, that's x squared. You multiply back everything. So it's x squared times x, which is x cubed. X squared times minus 1, that's minus x squared. Guys, if you subtract, you can see this term and this term are the same. Minus x squared and minus x squared are also the same. So by subtracting, it simply means that was going to give us a 0. But there are remaining terms, even though you are obtaining a 0 there, there are remaining terms, the minus x plus 1. So you're going to divide, you're going to drop these terms, then you divide. Minus x to this x, that is a minus 1. Minus 1 multiplies everything. So it's minus 1 times x, which is minus x, minus 1 and minus 1, that's a plus 1. So in this case, we can also notice, just like what we saw here, these are exactly the same. Guys, minus x, 1 and 1, they're just the same. So by subtracting, you obtain a 0 there. So this is it. You divided by x minus 1 and you got an exact factor. That's a factor that you're obtaining. So remember, I explained before, 6 over 2, if it is equal to 3, the product of these two must give us a 6. So when you divided this, you got x squared minus 1. So it means our f of x, which is the x cubed minus x squared minus x plus 1, is simply the product of these two terms. What was dividing the x minus 1 and what we got, which is x squared minus 1. So that's it. And by having this, we can notice that this is simply a difference of two squares that we are having here. Remember, 1 is a perfect square. This is the same as 1 squared. So we're going to apply our difference of two squares. And this tells us these two brackets, they are the same. So this is same as x minus 1 squared into x plus 1. So you can even start with the x plus 1, it's up to you. You can start with x minus 1, it's up to you. So it means this in a factorized manner is going to give us this. We have factorized. So it was just like a long way of the factorization. You have to apply the factor and remainder theorem to factorize. Then after that, we apply our partial fractions. Now, remember, we wanted to express this into partial fractions. So this whole part that we had here was going to be like this. So this was going to be minus x squared plus 7x plus 2 over what we got from this factorization, which is the one that we are factorizing, where we got the bracket of x minus 1 squared into x plus 1. So you factorized that. That was the purpose of the factor and remainder theorem, x minus 1 squared into x plus 1, like this. So this we can express into partial fractions. Remember the concept of our partial fractions, guys. How do you operate with your partial fractions? I'm just going to remove this part. We have it. All right. So remember, from our partial fractions, there we have got a repeated linear, that is x squared, then a linear. So remember the repeated linear. You can start with the a over that x minus 1 squared. plus b over x minus 1, or you can start with 1, increasing until you obtain a 2. So I'm just going to increase that a into x minus 1. That is the first part, which is raised to the power of 1. Then you move on to b over x minus 1 squared. That is what you have. You're done. If it was to the exponent of 3, you move on c over x minus 1 to the exponent of 3, and so on and so on, until you obtain the power that is presented there. So 1, 2, we are done. Then the next term is just, the next expression, this bracket is just a linear and normal linear. So it's just going to be c over x plus 1. There's nothing special about this. Or we can have this as a quadratic if you want, but have it as a linear, which is a repeated linear like this that can be of advantage. So from this, let us find a, b, and c. Remember, our concept is not going to change. This whole numerator of minus x squared plus 7x plus 2 is equal to a into what? The x minus 1 into this. There are two of them. So we are going to remain with 1, x minus 1, and x plus 1. Plus b, x minus 1 squared into this x minus 1 squared. They cancel. You remain with what? X plus 1. So that is going to be x plus 1. Plus, move on to the c. Do the same. All right, sorry guys, let us see here what you're gonna have. So there we're gonna do the same on c. The x plus 1 and x plus 1 cancels, meaning to say we are going to remain with that x minus 1 squared, because this one and this one will cancel. So you remain with what? X minus 1 squared, like that. So this is what you are going to use to find the values of a, b, and c. All right, so let's start with the bracket because they are linear factors. So you can even choose to let this bracket of x minus 1 to be equal to 0. So if we let x minus 1 to be equal to 0, it means x must be a 1. So when x is equal to 1, we're going to substitute a 1 here, a 1 there. You find your value. All right, so when x is equal to 1, this was going to give us 8, which is equal there. That's a 0 there. We substitute a 1. Also, this one was going to be a 0. So you're going to have 1 plus 1, which is 2b. So that will be 2b divided by 2 by 2. There we've got our b. That was going to be a 4. Okay, so let's move on to another part. We can work with the bracket of x plus 1. If we let this bracket of x plus 1 to be 0, it means x is what? Minus 1. So when x is equal to minus 1, substitute minus 1 in place of x. So it will be like this, minus 1 like this, plus 7 into minus 1 plus a 2. So that is the proper way, and you get a 6. You get a minus 6 there, which is equal to, that's a 0 there. Wherever there's an x plus 1, that's a 0 there. So there we're going to substitute a minus 1. So that's minus 1 squared, which is going to be 2 squared minus 2 squared. That's a 4. So that'll be 4c. So you can simplify that, guys. All right. So there we've got 4, positive 4c, just divide by 4 by 4. So c is equal to what? That's negative 3 over 2. If you reduce this, so you can expand the brackets. It's up to you. Or you can choose, since we are just left with one unknown, which is a, you can choose any letter of your choice. You can even choose just to expand. It's up to you. Or you can just choose any substitution. You substituted minus 1 here and 1. So you can even choose to let it this way, guys. This is what I'm trying to say. You can just opt, like we do not have a 0 there. When x is equal to, suppose you're just left with one constant. So you can choose to expand. It's up to you. Or just let x to be equal to 0. That's a 0 there. So it means we're going to remain with a 2. When x is equal to 0, we're going to have a 2. In place of x, you substitute a 0 here, a 0. That's 0 minus 1, which is minus 1 times 1 times a. Remember, there's a. So minus 1 times minus 1, that will be minus a. You do the same thing in place of x on this part. That's a 0 there. So 0 plus 1, that's a 1 times b, which is, we got our b as 4. So that was going to be plus 4. Remember, that's a 4 there. B, we have it. So that's a 4. So the same thing, you substitute here. That's a 0 there. 0 minus 1 squared, which is 1 times c. So 1 times c, we have the c, which is minus 3 over 2. So that was going to be minus 3 over 2 at the end. So you substitute the value of C because you have it. So when X is equal to 0, it's a number that is easier to work with. Yes, you can choose any number there. You're still going to have the same value of A. You can even choose when X is equal to 2 because you do not have that. Or expand brackets. I talked about that in the previous part that we had our simplifications. So now we can calculate the value of A. Just gonna simplify. 2 is equal to minus A. 4 minus 3 over 2 was going to be 5 over 2. We can even transpose this to the other side. That will be a minus. So 2 minus 5 over 2 was going to be minus half, which is equal to minus A divided by a negative. So therefore, A was going to be a positive. This and this was going to cancel. So there, A is 1 over 2. So we have got the value of A, the value of B, and the value of C. All the values that we wanted here are there. So in this case, guys, I'm just going to erase, guys, okay? I don't know why is this now slow, but let us just try and see if we're going to be able to finish here. So we calculated our A, remember? Just now we got our A, which is 1 over 2. All right, so I'm just going to move this part, guys. We have our values, so let us just substitute these and see what we are going to have thereafter. Do not want this. So this is where we are going to substitute. So guys, you are not supposed to do this. I can just erase because here there's a lot of things now to consider. So our A, we got 1 over 2. So it was supposed to be like 1 over 2 like this. But guys, 1 over 2, remember, if a fraction and a fraction, so just take the 2 into the denominator there. So it is going to be 1 over 2 into the bracket of X minus 1. Or just leave it like that. If you do not understand, like, what does it actually mean in the simplification, you can just even leave it like that. Okay, you can just leave it like that. Okay, I'm going to explain that way also. You can just leave it like that because I'll end up even confusing you here. So you can just leave it like that. 1 over 2 into X minus 1 plus our B, which is 4. Remember our B here, over X minus 1 squared. Then our C, which is negative 3 over 2 over what? Over X plus 1. So I'm going to explain about these, the fractions that we are given in our simplification. So this is it. Remember, to have this, to express this into our partial fractions, it was because we wanted to integrate this. This is the whole part that we had, and we now expressed this into our partial fractions. So meaning to say, in actual sense, we are supposed to write this as X plus 1 plus this remainder that we got, and this remainder now expressed into partial fractions is this remainder that we have. So it was going to be plus 1 over 2, that 1 over 2 that we had, over X minus 1 plus the 4 over the X minus 1 squared minus, so this is, guys, simply minus there. So it's just going to be minus 3 over 2, everything over what? Over X plus 1. This is what you were supposed to obtain, representing the whole part of our X to the exponent of 4 minus 3x squared plus 7x plus 3, everything over X cubed minus X squared minus X plus 1. So we have expressed this into a fraction, which is simpler fraction to work with. And this can be integrated because the whole question here was an integral with respect to X of this fraction. So now that we have got the simplest form, it means we can simply integrate with respect to X, integrate everything that we are having on this other side with respect to X. So let's try and integrate. So that is where now the part of our fractions plays a role. So there we're going to integrate each term, X with respect to X. Remember the integral, guys, just add 1. That is 1 plus 1, which is 2. So that's X squared over the new exponent, which is 2. 1 is a constant, so it's just going to carry X. So that's X. Remember, if you are integrated, this is a constant. So you take the constant, that is 1 over 2. Then it means you are left with 1 over X minus 1. So guys, remember 1 over X, that's a ln of x minus 1. The same thing here, we are going to have a 4 over this. So it means we are going to have 4 times the integral of this. If we take this 4, it means you are going to remain with 1 over. So we need to integrate 1 over this x minus 1 squared. So depending with the way that you are going to use, how are you going to integrate x minus 1 squared with respect to x? You can use substitution. It's up to you, where you can let u to be equal to x minus 1. You differentiate u with respect to x that you are given, and that's a 1 in this case. So that means du is equal to dx. So this, it means we got 1 over x minus 1, which is u to the exponent of 2. And this dx is the same as the du, as we obtained that du is equal to dx. So it means this is simply going to be a du, which is same as the integral of what? U to the exponent of -2. Remember, we can raise this to a negative exponent. So integrating this is simply going to be a +1 there, which is u to the exponent of -1 over the new exponent. That's -1 over u from our simplification. Just drop the exponent there. So that's -1 over our u, which is x minus 1. So we can integrate this, and thus we are going to obtain -1 over x minus 1 like this, plus the constant of, right? No, guys, we still have something there. So that is the substitution that you needed on this part. I'm still think that we still have another. So there we integrated the 1 over. So remember there, the 4 is there. Then we do the same thing. So this is not a plus, but it's -3 over 2 there. So it's going to be minus the constant, -3 over 2. By taking out the -3 over 2, you're left with 1 over x plus 1. So this is the ln of x plus 1. Guys, remember, this is a direct integral. We talked about this on a separate topic. So this is the whole integral of your question. This question that you're given there was going to give you this part, and you can just try and simplify this, which is x to the exponent of 2 over 2 plus x. We do not have like terms here. So that will be plus 1 over 2, the ln of x minus 1, then 4 times -1, that will be -4 over x minus 1, and this is -3 over 2, the ln of x plus 1 plus the constant of integration. So with this, this we are done. All right, so there we just have to be very, very careful in the simplification that we are going to have in the later stage that you are given. So in this case, we have got everything that we have. All right, so there, okay, there, remove that part that I wanted to check. All right, but that is it. Let us consider more questions on that type of a question, or whenever you are working with these typical questions, how are we going to be given these questions, and how are you supposed to integrate that? All right, so let's check another part. Like we saw that we still have another integral again, but this one is already in the format that is easier to actually express to the partial fraction. So that is, we have got x squared minus 5x plus 16, everything over 2x plus 1 into x minus 2 squared with respect to x. So if you are to consider this, we can see that there is already a 2 there. So by expanding, it means already there is an x squared, which will be multiplied with a 2x. So the x squared and the 2x will be something like 2x to the exponent of 3. So meaning to say the numerator compared to the denominator, it has a lesser degree. So this is a normal or a proper fraction. We can just express into partial fractions. So you do not need to expand able to check that. Just work with where x is. X to the exponent of 2, it's what? It's x squared. And it must be multiplied because there's a bracket there with a 2x. That is the part that you just test. And you see the exponent, because you just check the degree that you're given there. So it is bigger. So it means that's a proper fraction. So in this case, we are just going to express into partial fractions straight this part. That's x squared minus 5x plus 16 over, there we're going to have 2x plus 1 into x minus 2 squared. So this is just a repetition of the previous question in the expression, because we had a repeated linear and a linear. So that is going to be a over 2x plus 1 plus, remember the linear, you're going to start with a 1. So it's b over x minus 2 raised to the power of 1, which is simply x minus 2. Then you move on to the x minus 2 until it is the power that is given there, which is 2. And that is exactly that we have. And with this, we can equate our numerator x squared minus 5x plus 16 is equal to, that is a into what? The 2x minus 1, the 2x plus 1 and 2x cancels. So you remain with x minus 2 squared. X minus 2 into this, you remain with 1 bracket there. So that is b into 2x plus 1. There we're going to remain with 1 bracket. These two, they cancel. So meaning to say, you're going to remain with 2x plus 1. So that is going to be c into 2x plus 1, like this. So that's what we have. And just like the previous case that we saw, guys, we're just going to work with the easier part, the linear. X minus 2 to be equal to 0, it means x must be a 2. So when x is equal to 2, substitute 2 in place of x. That was going to be 10 is equal to, it means that's a 0 there. And that's a 0 also. So you're going to substitute here a 2. 2 times 2, that's 4 plus 1, which is 5. So that will be 5c. Divide by 5 by 5. So c was going to be a 2. All right, so we can also work with a linear bracket. There is a linear bracket, 2x plus 1. So if 2x plus 1 is equal to 0, it means if you solve, x is going to be minus half. So when x is equal to minus half, it means every bracket of 2x plus 1 is a 0. So that's a 0 there, that's a 0 there. So you're going to substitute minus half on the left-hand side, and that was going to be 75 over 4. You substitute minus half in this bracket where a is, you're going to obtain 25 over 4a. So you can solve for a by dividing by 25 over 4, by dividing by 25 over 4 like this. So this is like this. So you're going to cancel. And there we have got the value of a, and a was going to be a 3. So we calculated the value of a, the value of c. We are just left with a b. So it is up to you. Are you going to expand or not? Like I said before, the expansion thereafter, it is in your hands. So instead, you can just to choose to work with a 0. You never substituted a 0 there. You can just choose when x is equal to 0, or you can expand. When x is equal to 0 there, you obtain a 16. In place of x, you substitute a 0 there. That will be 4 times a. So it was supposed to be 4 times a. But remember, you calculated a. So 4 times 3, that's a 12. All right. So you substitute the value that you obtained. Okay. It was supposed to be 4a, but we have the value of a. Okay. The same thing. If you substitute a 0 here, that's a 0 plus 1, which is 1. That's a 0 there, which is minus 2. So we are going to have minus 2 times b. And that is what we need to calculate. So it's just going to be minus 2b like that. Then in place of c, we do the same thing. You substitute a 0 here. That was going to be 1 times c. And our c is 2. So 1 times 2, that's a 2. Okay, remember you calculated this. So we can calculate the value of b just like that. So 16 is equal to 14 minus 2b. That's a 2 is equal to minus 2b divided by negative 2 by negative 2. So b was going to be a negative 1. From this, we have a negative 1 there. So you have the value of a, the value of b, and the value of c. These are the values that we wanted to obtain. So what we are simply going to do is to substitute. So guys, I'm just going to remove so that we do not have a lot of things here. So this was going to be a. In place of a, now we can substitute our a that we got, which is 3. So this was going to be 3 over 2x plus 1 the b, which is minus 1. So that is minus 1 over x minus 2. Then the c, which is a 2. So that's 2 over x minus 2 squared. So that's it. With this, because we have got this whole part that was given and it was supposed to be integrated with respect to x. So also we can take that now and be integrated with respect to x, just like the previous case that we had. So as you can see, it's just a repetition, guys. What we had, only that the first part we had to apply the long division. But if you check the brackets thereafter, it's just a repetition of what we had before. So it means we are going to integrate just like before. But now take note, there is a coefficient there. So remember, I said on those integrals, the integral of 1 over ax plus b is going to be 1 over a, the ln of ax plus b, which is, this is a linear. So it's 1 over the derivative of this, 1 over this. So if there is a constant, there is going to be constant over that. Meaning to say there is a constant, which is 3. So it's 3 over these 2. The ln of 2x plus 1. Okay? There is just a normal, guys. We do not have like a 2, like a 3. So it's just going to be as it is minus the ln of what? Of x minus 2. So there, using the substitution method, just like the previous case, we are going to integrate this as 1 over x minus 2 raised to the power of 2. So you're going to use that. U is equal to this, guys. It was just going to be the same part, just like what we got. So in this case, it was going to give us 1 over x minus 2. It was a negative 1 over x minus, just like the previous case, guys, plus the constant of integration. So there, you use your substitution, just like what we did the previous one. So that's it, 3 over 2, the ln of 2x plus 1. There we've got a minus x minus 2 plus, that's minus there, 2 times the negative, because this is same as over 1. So it's minus 2 over this. So it's going to be minus 2 over x minus 2, 1 times this, x minus 2, plus the constant of integration. So that is it. With this part, you are done. So you just need to make sure you work with more questions of this typical nature, working with your partial fractions. Go through the introductions, guys. The introduction is there. I think we can understand much better from there, because these are now revisions that we are talking about. So let's work with more question papers. If there's a question paper that you feel like you do not understand on this partial fractions or any other part of our mathematics N6, let me know so that we can work on that.